It took me coming in here to realize, wow, I'm doing this wrong.
I originally had made it very large and then I changed my mind apparently. Right. I thought it would throw you all off if you got a huge negative number or something for the C. Okay, so before we start doing some problems, we're actually going to start by defining some antiderivative properties and rules along with common antiderivatives that we might come across. That way they're in one nice convenient place when we start really getting into the U substitution antidifferentiation. Are you done? Devin's not done writing.
How long are these notes?
It took me 9 pages.
9.
Well, like 9 sides of paper. We're not going to get through it today. It's probably 3, yeah. It's probably gonna take us a couple days.
Do I have to take the
Okay,
so hear me out. First page today, second page tomorrow, third page. Or push it back.
Well, you know there are 5
The AP
pieces of
test
paper
is
here,
paid for.
right?
No, if there's, you know what, if there's a snow day, I'll write
Any
you
of us
notes
somehow pass.
I'll write you
Yeah.
notes.
But it doesn't actually affect your grade.
And they're really all just
So there's
examples.
no
We might not
downside
do
to
all the examples, which might be kind of nice.
But if you like upload the notes, I'll write them all.
See, I
Okay.
like writing
I'd
the
rather
notes
write
when
the
you
notes and
upload
watch
them
it 5
because
minutes.
I like to understand what's going on as I'm writing it.
Right, I get
Helps
that.
me remember the stuff.
Okay, so let's do the rules.
I want to go home.
What part of that was rude?
That was literally like the
That was
nicest thing.
very-
How was that rude at all?
Aggressively do you.
Yeah,
it's
like,
like
you're
passive
fine.
aggressive.
You do whatever you want.
It was passive.
I didn't care.
See?
He was giving. Now I'm being rude.
Give me 3. We don't have rights.
Okay, I don't have rights because I can't say what I like to do without being rude, apparently.
I'm about to beat up everybody.
For real. Okay. So the first thing we need to point out is that we now have 2 different types of integrals. We have a definite integral, which has numbers on this integral s, and we have an indefinite integral that doesn't have any numbers or values there. When we're doing U substitution, we are primarily working with indefinite integrals. So I don't know what I'm solving my integral out, which is why I'm finding my general antiderivative. So the first property we have is that if there's some number in front of my derivative function, I can pull that out and put it in front of the integral and then multiply it in after I've taken the antiderivative. This works for any positive or negative constant value. The second one, just like we had for definite integrals, is if I'm taking the integral of 2 functions added together, that can be separated into the first function plus or minus the second function in separate integrals.
Have we written down these?
Yes, we did the same thing with definite integrals, but it applies here as well.
Okay.
So I like to make sure they're written both places. I'll move it up in a second, Ethan. Next, we're going to look at power formulas for antiderivatives.
Are those the only 2 properties?
Yes. And these we've already kind of talked about, but we should still write them. So the first one, we know that if I'm taking the antiderivative of a power function, I just increase the exponent by 1 and then divide that new exponent out. And then, of course, I have my plus c constant at the end. This works for any exponent that is not equal to -1, because when my exponent is -1, then it's a logarithmic antiderivative, not a power rule antiderivative.
What is it, -2?
It works.
So only a -1 is
Only when my original exponent is not -1 can we use this rule. If it is -1, then it's a natural log problem. Which brings us to our second power formula. If that exponent is -1, then the antiderivative is equal to the natural log of the absolute value of u plus some constant c. So those are our only two power formula rules. So we're gonna now go into the trigonometric functions and formulas, just so they're in a nice convenient place.
Are we just writing?
For right now, yes.
Are we only writing the formulas today?
No, we're gonna do examples today too,
How many?
however many we can fit.
In the whole class period?
Probably not the whole class period, but pretty close. Let's see. So if I'm taking the antiderivative of cosine, what is its antiderivative? Positive sign. If I'm taking the antiderivative of sine, what is the antiderivative of sine?
Negative.
Negative cosine.
Why are we?
No different than having an x. Because we're going to be doing U substitution, so it's just nice to see it in a function. I'm sorry. What if I'm taking the antiderivative of secant squared?
Secant, cotangent, or secant.
What's the antiderivative of
It's
secant
like
squared?
1 over.
Nope.
No, that's negative 1.
Nope. The derivative of secant is secant tangent. But what's the antiderivative of secant squared? So what derivative gives me secant squared? Tangent.
Square.
It is tangent.
Now I think my integral's like this, so now I'm writing.
What if my derivative function is cosecant squared? What's the antiderivative of that? Anybody remember?
What is it?
Cosecant squared.
I feel like it's negative tangent.
It's negative cotangent. Because the derivative of cotangent is negative cosecant. So if I take the derivative of negative cotangent, it's positive cosecant squared. We have some more. So what if my derivative function is secant u tangent u? What is its antiderivative?
Secant.
Secant. Because the derivative of secant of x is secant x tangent x. Another one we have is the cosecant u cotangent u. And its antiderivative is what?
C.
Anybody remember? What do I take the derivative of to get cosecant x cotangent x?
I feel like negative cosecant.
It is negative cosecant. So those are our trigonometric formulas or antiderivatives. They're really good things just to have written on your paper. If I give you a cheat sheet for a quiz or a test, I highly suggest you write these.
Are we doing inverse ones too?
We are not going to write the inverse ones, but you're more than welcome to put them on your cheat sheet. Well, yes, you'll have to use them. Okay, so now let's do exponential and logarithmic rules and formulas.
I think this is the longest we've ever done a class period without writing examples.
I think it is too.
We don't really just start.
Sometimes we're like one definition, but like
Because the easiest way to learn calculus is through examples. Today we're just right now we're just writing rules and formulas. So the first one is, what if my derivative function is e to the u?
Because
What is the antiderivative of e to the x? E to the x. So here it would be e to the u and then plus c. What if I have an exponential function that has a base that is not e? So if my derivative function is a to the u,
Isn't it e to the x times natural log of a? Something like that?
close. It's actually a to the u divided by the natural log of a. And then plus c.
Okay, good.
Use cheat sheet.
Wait, you don't get cheat sheet for.
For the AP test, no.
Oh, no, we're just gonna fill out.
But on the AP test, you won't see a lot of ones like this either.
And on AP test, I'm gonna get a big fat.
No, don't say that. Never had a 0, we're not gonna start with you.
Ryan Long didn't
We're
get
gonna
a
start
zero,
with me.
he drew a chicken.
You drew an octopus.
Oh.
And he's gonna get a
He
zero.
told me all about it, believe
He's
me.
gonna get a 0.
You didn't get a
He
0?
got one.
Oh, no, I swear he got, okay, well, he thought he was gonna get a 0
I
because
know, did
Miss Ryan DeLong, Miss Mazak flipped her lid, man.
Oh, and
She's
then
not the one
you
taking the test, why did she?
Oh,
take it?
Because it reflects back on us, like what grade you get. So what if my derivative function is natural log of u?
Is it 1 over u?
It is not. It is actually u times the natural log of u minus u plus c.
What the heck?
Yeah, so that's why we write these.
Oh my gosh, can I go to the bathroom? My
Yeah.
complex is really like stabbing my.
Yeah, go for it, honey.
You made it. U minus u plus 0.
You know, everybody's been having problems with their contacts today.
I know.
That's
That's
true.
Jasmine
Okay,
got
no
one
contact.
during Spanish.
She's
I
like the
put
third
mine
one.
backwards 3 times apparently this morning.
Yeah,
I
she's
just,
like,
I
I
just
took it out
don't
and I
take
cut it
them
back
out.
backwards.
Take off swimming. I clean them then. Put back in. I sleep in them.
Well, some of them you can.
So
Are
let's
there some
say
that you can't?
that I'm taking the antiderivative of a logarithmic function
Wait,
that has base a and u plugged into it. The antiderivative of this one would be the natural log of u over the natural log of a. That's another way to write the integral, which makes it easier to simplify this.
Binders are just so ineffective. This big old metal thing.
Into its antiderivative.
For log of LOX.
Nice.
Wouldn't we also be able to use?
Can you imagine pull out some math stuff?
Like, can't it be log base anything of u over log that same base over a?
Start over.
Well, we use the natural log to, well, it would be log of u over log of a, but it's easier to take the antiderivative of a natural log versus a log.
Okay.
But yes, all the same rules apply for log and natural log. But yes, that would be your change of base formula.
How natural log looks.
Well, that's why I do a curly for a natural log and a straight for, because I don't like it to look like in.
It just makes me mad because natural log, NL.
I know, but it's ln.
I'm gonna have to have a word.
Okay, so that was the last one that we have. We are going to clarify what U substitution is or how it works, and then we're just going to go into examples.
You want us to write that
I'm actually not ready yet.
Well, yeah, you should definitely write this next little piece.
Actually not ready.
No,
Just give us like all the definitions.
this is the last of the definitions.
All the pages, all of them, every.
All the rest of these on the other 7 sides of paper are all examples.
I
We're all
think
having
you're right.
I'll bring those.
It's really just Miss Banks. She's kind of
Honest.
Exactly.
Where do you do this?
I don't know, yesterday it was in warm.
somebody left it outside of my door when I got here Monday morning. Tuesday morning, just kidding.
You have no idea what it was?
Nope, but I like it because he was my math teacher, so it's kind of fun.
I kind of thought you like found it and you're like.
Wait.
No, somebody left it outside that door Tuesday when I got here. This. That says Mr. Matizak
Oh,
B203.
this is okay.
Is this your
Is
room?
that like actually an
Yeah.
old one, or is it? Wow, nice. You probably just scuffed the wall.
I probably did.
Is that like actually an old one, or? Is
I think so because it's a little worn. So since we know that U substitution unwinds chain rule, we're going to clarify how to take the derivative of chain rule and how it fits together. So as a reminder, when I take a derivative of a function inside of a function using chain rule, it is the derivative of the outside times the original or with the original inside times the derivative of the inside, which is why when I antiderive it, that entire g derivative right here completely goes away, which is why we pull things out and why things disappear when we don't think they should. because they weren't originally part of my function. So now, well, I'm trying next year. So now, we're just gonna do
It
some
would just be
examples.
better if there were dual credit.
I'm trying to get dual credit calculus and dual credit statistics next year.
But would
Oh,
you
but
have an AP
We
calculus
already
too?
got dual credit when we didn't get it, and now they're gonna get calculus when we didn't get it.
I'm
We have to pass a freaking
Is
test.
it easier to
Like,
get
no
that
one's
dual
gonna
credit?
pass.
Because it's an easier class?
Well, dual credit, you're guaranteed to get the credit regardless of how you
Well, I mean,
perform.
for
I
you,
just gotta
like,
get a C.
did
For
you have to
me?
take less classes to make pre-cal dual credit?
No, I had to take the same amount for my, like, I had to get my master's as the only qualification
Dual
for
credit's
the.
so
How
much
did you go
easier
to
for us.
So I'm in the process of getting my master's. I'm over halfway through my degree program.
And
So
then it's like, whatever.
technically, I wasn't supposed to be allowed to be dual credit certified yet because I
That's
haven't.
also like all the teachers.
Because I haven't been teaching this content for 3 years. This is my 3rd year. So I had to do 3 years, then you have to do other stuff, but they accepted me anyway. So
Cool beans.
now I'm trying for calculus and statistics next year.
Statistics.
Who's gonna take- who's gonna take-
At
Me,
least I
I'm
have a
probably-
teaching license.
Leo and Tim.
Yeah.
Or anyone else who doesn't want to take calculus.
Oh yeah, that's true.
Statistics applies to way more people. I think every high school should have it. I don't know why we don't, but
In Florida, they had.
I think it technically applies to everyone on the planet.
it does.
Is it easier? Yeah, what are we doing?
I did. I do not hate you. I love you all. But we're still doing this.
I already left. I'll leave it.
I read a chart yesterday about how like wood
I love
burns
to
and
see
like
that.
what's good to burn and what's good to cut and all that. It's interesting.
Thank you.
'Cause I thought I read maple when I wrote examples.
Oh, okay.
So how does wood burn?
Yeah, I don't remember.
If I can literally Google anything on, okay, here's the thing. If I'm in Miss Simmons' bio class and it's dual credit and I can Google all the assignments and find all of the answers,
That's why I make my own.
why
I
do
hate
I
that.
have to be in that?
I hate that.
Yeah, what are you doing over there? You
Don't
cheating?
even care.
We need to report.
I don't cheat in anatomy, there's nothing to cheat off of.
Okay, first example, I have the indefinite integral of x to the negative 2 power dx. This is a power rule. You actually know how to antidifferentiate this already. So I would like for you to do that. Find the antiderivative. So it's a power rule, which means the exponent is going to,
Increase by 1 divided.
and then divide out that new exponent, yes.
If you hit yourself on the side of the head hard enough, you can actually like break through your skull and make your brain.
Okay. What the?
Like right here, it's a weaker part of your skull.
Wait, right here?
Yeah.
Wait, what did you just?
I don't.
Oh, because I'm adding one. I was trying to pull up this -3.
No.
and then
I increased it by 1, then divided out the new exponent, and then this was just me simplifying it. This looks a lot nicer, but this would also be an acceptable answer.
That looks terrible. So,
That looks awesome.
Someone-
Yeah, but it's a positive exponent.
yeah, I like that more. I found that I hate more than fractions. Negative exponent.
Okay, questions on that one? No, super easy. Let's do another one.
Do I need calculus ever? Okay, yeah.
That's funny.
Fine, she says make a joke on your thing if I don't write B in the
This class.
Calculus isn't a joke when it diminishes my mental.
Wow.
DT. Why is DT? So is that?
It is dt because the variable present in my function is t. Whenever you see something like this, I'm always going to suggest that you rewrite it so the dt is separate. It makes it a lot easier to see what function I'm actually looking at. So this is the same as 1 over t squared plus 1 times dt. And I know when I see something like this, it is a what? Inverse trig function. So I need to go back and look at my inverse trig derivatives, and I need to see which one gives me 1 over x squared plus 1.
Tangent.
It is going to be tangent, which means the antiderivative here is tangent -1 of t plus c.
I don't understand. Never mind. I just don't like it. I don't like the DT.
I don't like
I
T's.
don't see why
Yeah,
it has to be
T's are annoying.
The dt,
Yeah.
it indicates that that's a derivative function.
Yeah, but like, don't I
Yeah,
know
but
that
you
it comes
ignore
from
it.
Well,
the game?
You should know it, but if it's not there, we have to question whether it is actually a derivative or not.
Why would you integrate it if it's not?
Well, maybe it's a trick question. We're not actually supposed to integrate it. I would not, but somebody could mess up, and you definitely should question it if there is no D something there.
Because then you can prove that you're right, you get the question right without doing anything.
Or you could just throw the question, or you could be just be like, I'm done. Like, you can't solve it because you didn't correctly write it.
I don't have the confidence to do that in math.
We're not done. Example C.
Whoa,
iPhone.
that's an
Oh, is that the
alarm,
left
we're
leg
done.
up? Is that the way?
I don't know what though.
That's what
What
they're
it say? It's the same.
That's her alarm from yesterday when
I
she
don't
put it
really
by her phone.
I don't like. I don't know.
So now I have this function, which is the addition of three different functions, which means that I could separate this into three integrals if I wanted to, or I could just treat each one individually and add my answers together. That's the way you should probably do it. It's a little bit easier that way.
Separate them out.
To just treat each one individually, or you could separate them.
X is just 2 to the X.
Yes, it is.
C. Plus C.
No? Well, it would be plus C if I was treating it separately, but I want to do all of them.
So if we do all of them together, then it's only plus C at the end,
Yes.
not
Plus-
plus like 3C.
Well, even plus 3C would just be a constant. You just say plus C.
Plus secant of X.
How'd you get secant of X, Deanna?
From secant of X tangent of X.
Okay, secant X, when I take the derivative of it, turns into secant X tangent X, which means it's the antiderivative of secant X tangent X.
And then the 1/2 is like, well, it's X, you would do X to the 1/2.
I'm thinking square root.
Yeah, that's what I'm
Times
saying.
square root of X cubed.
2/3 times the square root of X cubed. Actually, 2/3, yeah, that would work. I wouldn't write it like that to start with. I would write it like that to start with.
If 3 has to be flipped.
Yeah,
What
so
do you
then
mean?
1/2 would be the square root and then the cubed would be the cubed. But I would write it that way just to avoid confusion.
Can I just run on the floor?
How did you get the 2/3 there, Liam?
It was 1/2. I added 1.
Well, that's how you got
Oh,
the 3 halves.
Because I did it by
And then.
Flipped it and multiplied it in, which is the same as dividing by 3 halves, yes. Everybody okay with that one?
Yeah.
No,
Anybody confuzzled? Aaron?
I get the 2 from her, but I don't know what is 2/3.
Okay, so
Like, where do you get?
it was x to the 1/2, right?
And then you.
Because that's what square root of x is.
Yeah.
I increased that by 1, so 1/2 plus 2/2 is 3/2,
Oh, okay.
and then I divided it out.
Because it's the antiderivative.
Yes. Yes, ma'am.
I said the derivative.
No, antiderivative.
I second.
Oh, thank you.
Let's go.
Confident applicant parent.
Now that her contact was stuff, maybe I
You know who else comments?
There was
Comments our parents a lot? Great.
Ooh.
Kind of weird.
I don't know how that happened.
Anna's on drugs.
Where's our, oh, there it is, never mind.
I wish also.
That's where the squiggly line was.
I'm just laughing at this.
So this is the integral of x times cosine of 2x squared dx. What do I immediately notice here?
That's
It's a chain rule problem because I have a function inside of a function, which means I need to use my U substitution. So I need to identify what my U is, which is the inside function. So what's my inside function here? 2x squared. I then need to take the derivative of that function,
So, 4X.
4x and then dx. Are we all okay with that? Okay, so this is the fun part. I need to locate 4x dx in this function. Do I have it all there? I have an x dx though, right? So what I'm missing is a 4. We can actually put stuff in to make it match whatever my derivative is. Just know we have to balance it back out here.
Wait, what are you talking about?
I need a 4x dx in here. Right now I have an x dx. So in order to make that a 4, I put a 4 in, but I also divide the 4 out.
Is that cosine gonna go away? be really cool
No,
if it
that
did.
cosine is gonna say,
We will get rid
because
of
it's
it.
my outside function.
You get to put some in there. We're gonna get a footprint.
Technically, we're
That's
multiplying it in and dividing it out. I just separated the fraction to make it fit my needs.
Like, you can't tell me this makes sense.
It
Like,
does,
you're just,
it's
like,
still in
plugging-
balance.
You're just plugging random numbers.
But
in,
like people
and you're like,
No, I multiplied by 4/4, which is 1, which doesn't change any of my values.
Where's the-
4/4. I just separate it into 1/4 and a whole number 4. Same thing. 4 divided by 4 is 1, so I didn't change anything.
This is the-
I know, this is a really difficult part to get through. Okay. So once all the pieces are there, I like to rearrange it so that it directly matches what my derivative should be. So I'm gonna move the 4x over with the dx. So this becomes 1/4 times the integral of cosine of 2x squared times 4x dx. Once my derivative matches,
Cosine of u.
well, what I'm just about to say. Once I get the derivative to match, I can replace the derivative with du, and I can replace the inside function with u. If you want to do that before, that's okay too. This is how I do it.
Wait.
So now this becomes 1/4 times the integral of cosine of u du.
Is that the answer?
I replaced 2x squared with u because that's what it's equal to. And I replaced 4x dx with du because that's what it's equal to. And it makes it a lot easier to antiderive this than to antiderive that.
Oh, that, but
Alright, I think we're
Wait a
done.
did you do this yesterday?
Yes, we introduced it yesterday.
No, I mean, like, I don't. This seems like a completely different process. than
No,
you did
it's
yesterday.
No, same process. Okay, so now I take the antiderivative of cosine. What is the antiderivative of cosine? And then my last step is to put u back in. So then my antiderivative here is 1/4 sine of 2x squared plus c. And I'm finished.
Why do you even change it back to u?
Well, we changed it to u to make it look a lot more uniform. So it's easier to take the this is a very simple U substitution problem. They get much more complicated.
No.
That's great.
So that's why I'm gonna ease you into it.
Let's do another one.
We are gonna do another one. How did we feel about this though? Was this terrible?
I wasn't about it yesterday.
Yeah.
Wait, what did you do about the du?
Well, it went away when I took the antiderivative.
Oh, okay.
Yeah.
So you simpled it to like what the chain rule would look like.
Yes, exactly.
So you simpled it.
I knew what you meant. It's fine. Okay, let's do another
I
one.
won't tell. I won't tell.
Okay.
You're not telling them?
None of your business.
Tom in the back of Miss Matizak's.
You guys are snitching. Oh, that was the stupidest thing.
I could have drop kicked that kid.
I already heard about this.
This Kurt stopped him.
Someone was a bunch of freshmen and they're talking crap and calling.
No, they were vaping, and she walked in and said, "You guys should probably go to class." And then they started like freaking out on her.
Yeah, and called her the C word.
No.
No,
but
she loved
Yeah.
And Jayla,
That's it. Tomorrow,
Jayla
if we
said
have
something
school,
about
all
it.
of us
in
Yeah,
class.
and then Tom said that she's
Let's
gonna
go
sit in
Yeah.
the bathroom because
Tom
they're
said
not
something about like
teaching
you guys are over there
Exactly,
snitching.
yeah,
It's
they
like
publicly
it's
see.
fine if like
I
they're
will
listening.
sit in the bathroom all third period.
No, it's like between every class.
Yeah.
Okay, we'll do it after.
I
SRT?
I went in there.
Yeah, come on.
Sounds good to me.
Let's go sit in there.
I went. Okay. Okay. Calm down.
Mr. Booger should like just chill in the back.
I really hope they never watch these videos.
I don't care.
Okay. So now I have the integral of 28 times the quantity 7x minus 2 cubed dx. Yes.
They're not going to be in your calculus class.
I know, not
One
the
time
point.
I walked in there before the class. It was the day that I just started breaking my spine for no reason. I walked in there, and they were all in there, and then they're literally vaping. I mean, I kind of nothing, and I was so mad. I was like, you guys are so dumb.
Well, they weren't even in the stalls. They were
No,
right,
no,
so
they're
U
literally
is
in the
7x
open.
minus 2, right?
Like,
This is
they're just
7x
like,
minus 2.
when you like walk in U-turns, there's like the area in front
It's
of
the
the
quantity
They're, like, in a
7x
circle.
minus 2 cubed.
Is U.
I had to
Is
walk
the
through
7x
stop
minus 2 will be, yeah.
So not
Okay.
without
Not
that.
the cube. The cube is the
Okay.
outside. I like to think about it as parentheses separates outside from inside. Okay, so we're getting back to math, and then you guys can plan whatever you want to plan. The first thing I noticed is that I have parentheses in here, which means that I had chain rule happening. So rotaring, I need to identify my inside function, which here is going to be what? 7x minus 2.
What? Can you just say the indicated good?
Because I had parentheses with the exponent outside.
Okay.
And then I can take the derivative of u, which Brock is going to be what? 7.
This is
7
a lot
what?
harder.
Plus C.
Nope.
Wow. We
What
took
do I
the
use to
derivative
indicate
of
I
that.
took a derivative?
DU.
dx.
Yeah.
I'm stupid.
Because my derivative was x.
When you, okay, so we take the, so you,
You're okay.
du is the derivative.
Is the derivative of my inside function? Yes.
Okay, so then,
Anytime you see a d, that means derivative. Pretty
okay,
much.
so then I'm gonna change that, and then put that in, and then it's gonna come out.
Yes.
So far,
And
all
then
we've done is
plug u
recognize the
back
parts.
in. Okay.
Plug the function back into u, but yes. Okay, let's keep going. I need 7dx to be present in my function. Is it there?
No, 28 DX. You have to divide out.
It is, but it's masked right now. Because 28, I can take a 7 out of that, so I can separate this into 4 times 7, which will allow me to rearrange.
What?
So this becomes 4 times 7 times 7x minus 2 to the cube dx.
Why are you making extra steps? Can we
I-
change 7 now?
Yes, you can move the 7 now. I do extra steps in case anybody's confused. So I separated 28 into 4 times 7, which will allow me to move the 7 down here with the dx so it matches my du. So this becomes 4 times the parentheses 7x minus 2 cubed times 7 dx. Now that I've done this, I can replace my u and du because this directly matches what I needed it to match. I can also pull that constant 4 out in front of my integral, which leaves me with 4 times the integral of u cubed du. And now this is a power rule function. So what is the antiderivative of u cubed?
U to the fourth over four.
U to the 4th over 4.
No, I think we some antiderivative.
It's okay. So this becomes 4 times u to the 4th over 4 plus c. I can simplify it. The 4 and the 4 in the denominator are going to cancel, leaving just u to the 4 plus c, and then I can plug my u function back in. So this becomes the quantity 7x minus 2 to the 4th plus c.
Okay.
That wasn't bad.
This might be dumb, but u3 is 7x minus 2 that changes to u. You just,
I've replaced 7x minus 2 with u temporarily
okay.
to make it look easier to differentiate, to
So just-
anti-differentiate.
Okay, so just like a temporary.
Yes, it's just like a temporary putting, I don't know, a block here instead of the whole building. Yes, Shepherd.
Okay, so do you always have to bring the number like?
If it's a constant, you can. It just makes it easier to work with. You don't have to if you don't want to. I could have left that 4 there and had 4u to the cubed, and then it would have been 4u4 over 4. It still works the same way. Just know that that is a possibility if you wanted to do that.
Just thinking out loud when we do D,
You just said we're not
just
done?
recognizing like, well,
Okay, yeah.
we're ready.
We're just recognizing, yeah, yes,
20.
it's exactly what we're doing. What time is it?
10:13.
We got time.
10:13 actually.
You should have us do one on our own.
No.
That's a good idea.
Kevin,
Let's
don't
not
suggest something. Okay.
You know what? I like that. Let's do it.
He's getting hurt.
Why do you always go
Then
there?
I don't.
It's actually a great idea because then it'll be less lost when you get.
Did you jump that high?
Oh, we don't have an essential.
We will. I'm like 5'10".
Wait, should we be
No, I'm skipping F temporarily. This is
Listen,
G.
if it has a square root in this problem,
That's why I skipped F.
Now.
So do I put G as F then?
Actually, this is.
I skipped F because you don't want to do it on your own.
Holy.
Why thank you.
Holy.
like this one's any better.
It is actually a lot better once you see what's happening.
Alright,
Well, I
wait,
don't
let us
know
know
what's
what's happening.
Well, I don't understand.
I'm going to let you struggle with it for a few minutes. Because when you struggle, no, you actually have to try.
Which one's the inside function?
What's inside the parentheses, Deanna?
There's two.
What's inside the parentheses with the exponent outside of it?
So that's the end.
That's your inside function U, and then go from there.
What if they both have enough? Would you use U and another letter?
They're
If one was cubed and one
you're
was
not
squared.
there yet. I would not give you one like that. Because that would be like
Could you do it?
Well, you can
Oh yeah,
cancel
you
out
can
two
definitely do it.
things.
You just don't want to.
Where you have to like make 2 problems and cancel both of them out.
Kind of. Yeah, I wouldn't give that to you, and you won't get that on the AP test.
Bro,
Wow, if it's like so advanced, when I get an AP test, wow.
No, that's like Calc 3.
Calc
What do you think?
Yes, 1, 2, and 3.
I feel like it's not 1, 2, and 3. I feel like it's like A, B, C.
No,
because,
it's
like,
1, 2, and 3.
But you don't ever use
AB.
constants in calculus.
Basic. 3.
Keep going. Once you think you're as far as you can go, try the next step.
I know that this is supposed to be somehow turned into a 4. So my dividing is 8 by 2.
I would definitely split
Wait a
the data
minute.
into something times something. Yes.
And you want to find your D.
Correct.
I literally can't even find the end of
You know, that's so cool. See, I like this, but you're also making questions that work. I don't like that. Like if we were just like picking a random function, it would get really hard.
Well, we don't pick just a random function because not every function has an antiderivative. Like, well, we can't guarantee that every function is differentiable. So just because we have a function doesn't mean that I was able to have a derivative of it or an antiderivative of it. So this really only applies to maybe 2/3 of the infinite number of functions that are out there. So when we're picking, we really are picking purposefully.
What kind of function would not be?
Well, like an absolute value function is non-differentiable at specific points. So for looking at it as a whole, it might not be differentiable on that. And that's going to be a certain thing. Typically, you aren't going to come across one that isn't in your math studies right now. What's that? Yeah, absolutely. Absolutely. Yeah. Whatever you have to do to make it work. Yes. Oh, wait, I don't know if you come too first. Yeah, she's my first son.
I got this and I'm oh wait. I have that as my antiderivative. Is that right?
I'm not saying it's
And
not.
now this is what I have.
Okay.
So I plug you back in because I can't get.
Correct.
Yep, you just plug you back in. Now, can you just come over? No.
I think Oh, I-
into the front too. Take that out.
You don't need to,
what was your D?
but you could.
No.
If you multiply the inside by y and the outside by y.
Right.
This seems very long.
And now I like it. Now just plug the function.
I get that a lot.
I
I
would.
get that a lot.
Okay.
No, antidifferential.
You get like a very long.
I didn't get anything. I don't know.
I'm not done yet.
I got it.
I definitely
I did
think I got the wrong answer, but
Well,
Oh my God, guys, I got it right. Look at me. Doing amazing.
And then. Nope, what are you missing? No. You disappeared because I antidifferentiated. What did I always put on the end of the general antiderivative function? Yeah. And then what do we do? Back in, yep.
Scared I lost something very recently.
I'm looking.
Don't
Move
look
your
at
hand,
me.
let me see.
Oh no.
Move it, move it.
That is what I have.
You're right.
I mean, I haven't written it yet,
Okay.
but I'm in the process
So-
of writing it.
That's what she said.
She said she'd like. I like that you separated this. What was I?
Maybe she
trying to
likes
say?
it because it makes her laugh because it's just so.
Oh, Liam.
So do I need to multiply the 4 into it, or do I multiply the 2 into
Gonna
it?
guess later.
You're okay.
something feels off for me.
I did something.
It felt pretty off for me, but then it was on the same one.
What?
Did you get?
No, okay, so that's okay. But that's what you do. And now what do you do?
Because it was
Does this match what I needed it to match?
in order
Oh,
to, wait, no, it was 2u squared.
yes,
And
you
then
should-
derived
you
squared,
should have
we
it
did
multiplied.
2.
Yeah.
Oh, wait, no, actually, times that quantity cube.
Oh my god. Oh, but that should be a 4. There you go. So 4 times. What did you do? Oh, I'm writing it all wrong. Okay, go to the board. Yeah.
Wait, can you look at mine real quick?
Yeah, in a second. Rotor, you're up. I'm not saying you're gonna do the whole thing. You're starting us off.
I'm gonna cry. She's literally letting you do what you do. Yep.
It seemed very like extensively long.
Take your notes, Bella.
Right?
What happened is like
Oh, okay.
But I already had an 8, so I just separated it. I didn't have to add it.
It was the second time.
Yeah, it just looks nice.
Nope. There's
What am
plenty
I
of
supposed to be
Y's in
doing?
there. Yes, sir. You, yes, sir.
Okay.
Good luck.
No, this is my antiderivative. And that's the derivative of the
You can't get worse than mine.
Should I write it over here?
No, and I took the derivative.
I don't care.
Wow, shots fired. Jeez.
Or 4y cubed. Okay. Because she had recognized what her inside function was. She found. No, that's not you.
Like that.
Keep going.
That's what I got.
Where's your real stem?
She's always judging everyone.
Hold on, Devin.
I don't like stems. They're too hard.
Yeah.
I don't want to do this. I'm getting major anxiety.
You put the wall between her more.
Yeah, Dad. Okay.
What are you missing?
I don't know.
No, no. dy, because you took the derivative of a bunch of y's. Okay, keep going.
I can't go past this.
Yes, you can.
Now I'm stumped.
Emily Roderick, I have a question. Is 4y cubed plus 8y currently present in my function?
No.
No, but can I make it be present by separating something else?
Yeah.
Yes, what can I separate?
An 8.
So separate the 8 and put things where it needs to go.
Are you sure?
And then I'll have you stop after this one, I promise. Okay.
You know, you're right, Liam. It is 2 over 3.
See,
The inside function is 1.
Because you multiply two.
For some reason, the reason I was thinking you
Oh
had
my
to
god, I
multiply
was doing the
y
wrong thing.
into it was because I didn't realize I was looking at the u instead of du.
What are you
So I was
missing?
trying to find next
What'd you
to y.
forget?
Okay.
And then
Okay, now do you have your du in there?
Yeah.
Do you have your u in there?
Yeah.
Okay, now put the pen down and pick somebody else to finish.
Lauren.
And then the reason that I was trying to apply y with 4 in was because for some reason I was like,
Make
yeah,
sure
I'm
there's an
gonna split
integral in
4,
front of the whole problem,
but then I
Lauren.
still have to take
We don't wanna
the
drop that
y
till we're ready to
out, so I'm
anti-differentiate.
I can't do the integral thing right, so that's not
So I ended up with
It's okay, it's just a
4y
weird S.
in the front, and that makes it off completely.
Yeah, you just have to see that it was the second part.
So you should get what, 2u squared du. Bring the 2 out front, and you have 2 times the integral of u squared du. And then what do we have to do? Anti-differentiate?
I didn't bring it up.
It doesn't matter if you did or not.
You know, if Mr. Penzak had left anything else in here of his, we wouldn't have ever mind it. Because it's probably like gone now.
Well, I have his picture over on the board. Apparently he hid a bunch in Miss Lowry's room when he retired, but like when he left.
So they were really the one, his idea was in that ceiling. They did drop some stuff.
I think she missed it. At least I know it's not you.
How'd she read it and tell him it was his?
That was mean.
Senor Kate, literally for like a year after she left would say, gotta transversize this and blow it up gigantically.
Yeah, he still
Did you ever see her phone?
Yes. Her phone, it was like one word.
You see
on
her
it. I know.
glasses?
She's such a sweet girl. She has glass contacts.
Huh?
Her contacts are like glass. Hey, show of hands, who had that antiderivative?
Show of hands, let me see them.
No.
Oh.
But multiply
Well, what
that.
if you
Like
just
you-
kept the
Oh,
two?
God.
What if you kept the y
I
on
had
top?
it 2 times out over 3.
That's fine.
Okay.
Same thing. Okay, so that is it for today. We will finish up examples starting with F tomorrow.
So is it us or Peter?